Okay, we're starting a new chapter today and we're starting a new type of lesson. You may decide that you want to watch the video all the way through and then go back and take notes. In fact, I think that'll probably be the best way for you to make the most sense out of what you're supposed to be learning from each lesson. So this whole chapter that we're about to start on this week is about identifying and graphing sequences. And a sequence is just like a pattern of different numbers, and we can actually kind of map the pattern using algebra. So a sequence might be something like 1, 3, 5, 7, 9. You recognize this sequence because it's odd numbers. So some things that I just want to point out to you. First of all, this ... here at the end means that it's going to go on forever. Some notation that you're going to notice would be something like, they might say f of n. Remember, that's just a function, and n is going to be the number term, and term is what they call each part of the sequence. So like each specific number is called a term. So f of n would be the sequence that we have here, and in this specific sequence, for example, f of 1 equals 1. What that means is that the first term is 1. We could also say f of 2, the second term, is 3. Or we could say the third term is 5. So again, this part in parentheses is the term we're talking about, like which position it's in. And on the other side, it's telling us exactly what the value is of that position. And you'll notice the other part of this lesson is talking about graphing. And just like we did last week, we can take these and write them as ordered pairs to graph and visualize what our sequence looks like. So remember, the ordered pair here would be like 1, 1. From this one, we're going to get 2, 3, and 3, 5. And we could even continue, right, and say like the fourth term in our sequence is 7, the fifth term is 9, so on and so forth. Okay, so let's look at a few different types of sequences. So there are two specific kinds. One is an explicit rule written in terms of n, and the whole point of explicit is that you can automatically determine the number in the sequence. So it's really easy. This is exactly what we did last week. They want us to find the first 4 terms. So right here is just my general rule. And to start finding terms, just like last week, we're going to plug in. Remember, last week we said it was easiest to write this as expanded before we started plugging in, so that's what I'm going to do. I'm expanding that out to be 3 times n times n. So when I find my terms, I'll do the first one with you. 4 to the first power equals 3 times 1 minus 1. 3 times 1 is still 3, minus 1 is 2. So I would write in my notes, f of 1 equals 2. You should probably write all of that in your notes. All right, I am going to go ahead and solve the others. So if I plug in 2, that's going to be 3 times 2. 3 times 2 times 2 minus 1. And if you work that out, you're going to get, 11. F of 3 is going to be 3 times 3 times 3 minus 1, which is 26. And then f of 4, 3 times 4 times 4 minus 1 should be 63. Like I said, that's going to take you a minute, but you should understand just generally how to do that. The last thing they want us to do is graph the sequence. Super easy, right? We're just going to draw ourselves a graph. N is going to be the same as our x variable, and then y up here is our value, so I drew that out really weird. If I count by, I'm going to count by tens just so I have enough room here. So the first one over here, 10, 20. In the ones you do today, you're already going to have the graph drawn for you, so that part's going to be easy. So 2, 3, 4. So I'm just taking a second to plot these different points. 211, 326, and I'm just estimating. Your notes don't have to be perfect. 4 is going to be up here at 60. And remember, this is a sequence, so I'm not going to connect these because I'm just talking about individual terms. So this is discrete, remember that word, and it should stay, we want it to stay unconnected. Oh, I'm running out of room. Okay, so remember, all of this is our explicit rule. That's exactly what we did last week, and you probably shouldn't have to watch this example more than just the first time. Let's look at what happens when we look at recursive. Recursive is just a little bit different. This is where you're really probably going to have to rewatch something. Recursive defines something in terms of its previous term. That means you have to go in order to get the terms. You can't just skip. For example, on the last one, we had just a general f of n equals 3n squared minus 1. I could have asked you to find the 50th term, and you could have just automatically plugged 50 in. You wouldn't have had to count all the way up to get that term. That's going to be something crazy huge. But you're going to see this one is just a little bit different. So pay attention just to some notation things. First of all, this is the term that we're trying to find. So f of n is the term we're finding. F of n minus 1, think about minus 1, that means we're going backwards. This is the previous term, and it's the term we have already found. And you'll notice here, they don't just give us a rule, they also tell us where to start. So f of 1 is our starting point, and we have to know that, or we can't actually figure out any of the terms. So they want us to find, it says find the first 4 terms, and I may even find the next 4 just so you have a better example. So for instance, f of 1, they already give us. They tell us that is our starting point and it's 3. F of 2, this reads 2 times, remember n minus 1 is previous, so 2 times the previous term. And I'm just writing that out so you can see. That means 2 times my previous term. If I look back, was 3. So I'm going to do 2 times 3 is 6. So this is going to give me f of 2 equals 6. All right, let me switch colors so we can see my next one. All right, f of 3 equals still the same formula, 2 times the previous, except now my previous term was 6. So now I'm going to do 2 times 6. That's going to give me 12. So this is f of 3 equals 12. All right, let's do one more. F of 4, it's 2 times the previous. So I look back one step, and my previous term was 12. So here I'm going to say 2 times 12 equals 24. F of 4 equals 24. All right, so now we have our first 4 terms, and you'll notice there's no way, since it always depends on the previous, I couldn't ask you to skip ahead and find the 15th term because you would have to know what the 14th term was to figure that out. So recursive is a little bit trickier because you can't just skip ahead. You have to do them all in order. I'm actually going to skip the graphing part of this one because I think that you all should understand that from last week, but go back and rewatch this specific example if you need to make sense of what I'm doing and how I'm getting these answers. All right. To know, in general, to know if you need to re-watch a video, you should be able to answer all 4 of these questions that you see right here. If you can't answer the questions at the end of the video, then you need to re-watch until you can answer all 4. That's how you know that you've gotten everything you need to out of the video and that you've taken all the notes that you need to take. Okay, so re-watch this if you need to, and we will talk about it more before we do your homework in class.